Okay, so in this lab, we're going to kind of pick up where we left off if we go ahead and look at our diagram. Um, and I'm going to, I should have had this already loaded. If you go to lab two or see, it's one of here. Maybe it's lab one. There we go. There it is. Okay, so in this lab, right, notice our public subnets, okay, are utilizing an internet gateway for internet access. So that has been set up. Now, the private subnets, right, are which our databases reside in. So what we're going to do is kind of test the feasibility of a NAT gateway. We'll create a NAT gateway in the public subnet one. You have to create them in one of the subnets. And we'll create another EC2 instance in the private subnet one. And we'll demonstrate how the EC2 instance in the private subnet, since it's private and it's not allocated a public IP. So again, remember the EC2 instances that we create have a automatic public IP address assignment. So each time we turn these instances on, they get a public IP from the pool, which allows them to access the internet through their internet gateway. Okay, the private subnets have no such public address, right? They're only private IP addresses. Private IPs are not routable to the internet. So the concept behind a NAT gateway is you assign a public, and this is an elastic IP. It has to be permanent. And so we got to make sure that when we're done with the lab, we delete the NAT gateway, release the elastic IP, because we can run a charge, but we'll have a permanent IP assigned to the NAT gateway, and the NAT gateway will be responsible for converting private IPs into public IPs before routing them out to the internet. Okay, so by creating another EC2 instance, you can kind of demonstrate how that works. And we'll delete the EC2 instance when we're done, and you'll see how we can access the internet through the NAT gateway. Okay, so a NAT gateway is a little bit different than an internet gateway. Internet gateway does no address conversion. It already assumes you have a public IP address like the EC2 instances, and then its job is to send traffic out to the internet for you, right? It's our gateway, okay, for devices with public IPs. For devices with private IPs, they cannot go through an internet gateway. They have to go through a NAT gateway, which is that private IP address to public IP address conversion. Okay, so we're going to go ahead and get started. It's not too difficult a lab. I'll minimize this window, and we'll go to our Launch AWS Academy lab. I've already done it, okay, and the AWS light should be green, so if you have to, pause the video and wait for your light to become green, and then just click on AWS. Okay, and then you're taken to the console. Okay, and then from here, we're going to go to our VPC. Okay, and if we go to VPCs, right, you can see our lab VPC is available. And under our lab VPCs, we want to double check that our EC2 instances are turned on and our databases are turned on. So let's do that first. We type EC2. They should power up when you start the lab. And your EC2 instances should be running. Now again, these EC2 instances utilize the services of a NAT gateway, okay, for internet access. And we were able to test that with an update. Okay, so the next step you want to do is go to your databases. Now, see if you can do that. What service do you go to check on your databases and make sure they're available? I'll pause the video for a second while you figure that out. Okay, so what you had to do was you go through your RDS, right? So you just go to RDS, click on it, and then click on your database instances. We got 2 of 40, and your databases should be available. At the end of the lab, we'll make sure to power down our EC2 instances and power down our databases. So let's go back to EC2 again. And again, we got 2 instances. Now again, if you recall from the diagram, our EC2 instances have internet access through the Internet Gateway. Okay, and we did that in an earlier lab. We connected the public subnet, anything in the public subnet 1 to an Internet Gateway, and likewise, same with the public subnet 2. So with that said, right, let me close this diagram. If you click on Web Server 1, for example, and you click Connect to test your gateway, you want to leave it as connect using EC2 instance connect. Your default username should be EC2-user. Click connect. Okay, so you could check for software updates. So like sudo yum update. Okay, it's already been updated, but for example, to test your internet connectivity, type the command wget google.com to get the IP address. Okay, and it resolves google.com into 142.250.31.139. So it's got several IPs connected to it. Okay, all beginning with 142.250. Okay, so you got the location, and again, so you have access to a DNS server out there on the internet, and from there you get the how long it took, and the index.html file that's associated with it. Okay, so you could do the same thing. You could actually try to ping that address. You could type ping. Most of these public IPs don't allow you to ping them, 101. Okay, and as you can see, you get successful echo replies from that address. Okay, so you have internet connectivity through your gateway. Okay, and so we just wanted to demonstrate that. You could type exit to log out. Okay, now anything in the private subnet, right, would have no such access. So these private subnets, right, because they don't have public IP addresses associated with them, they will need a NAT gateway for internet connectivity. So we can emulate that. First thing we'll do is we'll create the NAT gateway. Okay, so under the services, under the left side, and it should be under one of these, let's type VPC in our search, hit enter. And then from here, you should be able to see NAT gateways. Okay. And then you want to click on Create NAT Gateway in the upper right. And you want to give it a name. Let's call it lab-nat-gateway. Now we're going to select the subnet in which the NAT gateway is going to reside in. Okay, it has to reside in a public subnet. Okay, so you got to remember that we want to choose the public one, US East 1A. Okay, so make sure your NAT gateway is actually in a public subnet. Okay, and we want the connectivity type to be public. And here's where you could run money, right? So the elastic IP is a permanent public IP address. Okay, so when we're done with the lab, we got to make sure to release it. Otherwise, if you don't access the lab for a week, right, you're hanging on to a public IP and you're incurring charges for it. All right, so we want to just click that elastic IP. Okay, and you already have a tag for it. And from there, you just click Create NAT Gateway. Okay, and then you can go back and you can see that the state is pending. Okay, now it's going to take some time for the state to change to active or running. So I'll pause the video while we're waiting for that state to change, because then we'll create a route. Okay, we got to say that anything in the private subnet going to any IP address not within our private subnet is to be sent to the NAT gateway. Okay, so let me pause the video and we'll continue on it here in a second. Okay, so it only took a minute. The status became available. Okay, so what we want to do is we want to go to route tables and we want to look at the different routes that we have. Okay, we have a public route and we have a private route, right? So we want the private subnet. We'll make sure that the subnet association aligns with the private route table. Okay, so we got 172.16.2.0. I got to pull up the diagram again, so it's hard to see. So you can see 172.16.1.0 is the private route for the private subnet 1. Okay, and we want to associate a NAT gateway. So we go back to route tables and we select the private route. Okay, make sure only the check mark is on the lab VPC private 1 US East 1A. Okay, and from here we want to go to routes and we want to edit our routes. And we want to add a route. So right now we have a route for a local, which means you have connectivity for everything inside that VPC, right? But you need internet access through your NAT gateway. So anything with a destination address of 172.16.0.0/16, which is your entire VPC, right? 172.16.0.0/16 does not need to go through a device, right? It's a local route. It doesn't go through a NAT gateway or an internet gateway. It's a local route and you have full connectivity to all resources in your VPC. Okay, that's what this route says. What we want to do is add a route for any other IP address. So any other IP address by definition is the internet. Okay, so we add that quad 0 route that I talked about in a previous lab that says, well, if it's not a 172.16.0.0 destination, then send it to my NAT gateway, because by definition, that's the internet. Okay, so we'll click add route and we're going to select the quad 0. Okay, and the target, we want to select NAT gateway and we want to select lab NAT gateway. Okay, and so you want to save changes to that. Okay, and from here you can double check again your subnet associations, right? What subnets are associated with this route, with these two routes that are in this route table? So you click on subnet associations, right? And it's 172.16.2.0. Okay, so they will have access to a NAT gateway. Okay, so if we want to test it, and if you want to create another EC2, and because we'll delete it after the lab's over, if you want to create another EC2, right, in this private subnet 1, 172.16.2.0 subnet, we can certainly do that. We can go to EC2. And from here, you want to click on instances running. And there should be a create instance. Maybe it's EC2 dashboard. There it is. Never mind. Okay. We click on launch instance. Okay. Under the EC2 dashboard, and click on the launch instance button. Again, make sure you're in the right region, North Virginia. And we'll give it a name. This time we won't call it web server. We'll just call it Linux server. Linux-server. And from here, we want to make sure Amazon Linux is selected. And we want to make sure the free tier Amazon Linux image is selected. Okay. The instance type, free tier eligible, T2 micro is fine. And okay, somebody just came in. Okay, so a key pair, right? You could select the key pair and you can go create key pair and you can call it Vaki2. Okay, and one thing to keep in mind, right, in future labs on Windows machines, like using PuTTY, you want to choose PPK, but we'll leave it at .pmm for now. We'll just go create key pair, and we'll edit our network settings, and we want to select our lab VPC. Okay, now we want to make sure we choose the lab VPC subnet private US East 1A, right? And the CEDR for that is 172.16.2.0. Okay. Of course, it's in a private subnet. Auto-assigned public IP is disabled. And we want to select an existing security group. You know what? Yeah, because the existing security group pertain to the web server security group. So we're allowing inbound HTTP and HTTPS and port 22, and outbound where anything can go out. All right, so we're fine there. You could choose the same security group. Ideally, right, you would want, if this was a separate server like a file server or an email server, you would want to create a new security group for that and only allow inbound ports, like for an email server, inbound email, like SMTP, I forgot the port number, which is port 25, TCP, I believe. And then you got POP for Post Office Protocol, which is TCP port 110. You would want to allow those ports and any encryption ports as well that are common with email servers, okay? So your security group would be different because it's a different type of server. But for now, the web server security group fulfills our needs, okay? And we've got our VPC and our subnet identified. We go to advanced network configuration. Nothing we need to do there. Advanced details. IMM instance profile. From here, we could just select the lab instance profile, which is fine. And all this could stay the same. Okay, we don't need to have a script that installs the web server because this isn't going to be a web server instance, okay? So there's no script needed here like we need it with the other previous EC2s, all right? And then from here, we're just going to select launch instance. And we're going to click on the EC2 tab up here, which takes us back to our EC2 dashboard. And then we're going to click on instances running, hit refresh, and we're going to have to wait for the status checks to pass on the Linux server, okay? But we'll be able to test internet connectivity to it. and see if it's passing through the NAT gateway like it should be. So I will pause the video while we wait for those status checks to pass.
What's a good word?
Okay, so the status checks are passed, and we're ready to test the server, see if the traffic is passing through a NAT gateway. Okay, so now that we have the Linux server running, right, and our status checks are passed, if you know, for example, if we click on it, we don't have a public IP address associated with it, so you just click on Linux server, and notice there's no public IPv4 address, but it has a private IP address. So by definition, it wouldn't be routable to the internet without the NAT gateway we had just created. So again, when we create the NAT gateway, you create the gateway first, and then you update the route table to associate the private route table to any IP address not in my routing table, send it to the NAT gateway. So that's what we did, right? So how do we test to make sure this Linux server has actually internet access, even though it's in a private network? So again, if you're going to put something in a private network or in a private subnet in AWS, then the only rationale for having a NAT gateway is one, for security, because it hides that server from the internet. The only thing that the internet sees is the public IP address assigned to the NAT gateway or load balancer, for example. It doesn't see the inside servers that are in the private subnet. And then the second reason is if that server does not normally require internet access, if it's just a back-end file server or an internal file server, for example, then just periodic software updates, right? And so you can actually test it. Now, given that this is in a private subnet, using the direct connect feature that we did for the web server 1 and 2 isn't feasible, and it's not going to work. So what you can do is go to the systems manager. So we go to systems manager, and just click Get Started with Systems Manager. Okay, now we got 3 managed nodes, so I'll expand this. So we've got web server 1, the Linux server, and web server 2, right? So if you click on Linux server in the private subnet, just go to, I believe it's Node Actions, and go to Connect and select Start Terminal Session. Okay, now you're logged in, right? So you can actually verify that this has a private IP address. So if you go through a few Linux commands, if you type ifconfig -a, right, you can see the private IP address associated with it, right? So 172.16.2.107 resides in the private subnet for 172.16.2.0. So again, the first 3 octets represent the network portion, and then this last octet, 107, represents the individual host, right? And then the net mask 255.255.255.0 is the same as a /24. Okay, so this server is actually in a private subnet. Now, without the NAT gateway, this server would have no internet access whatsoever. Okay, so you could do a couple of commands to test it. For example, if you want to verify that you have internet access, we can go ahead and try to pull a software update. So type sudo yum update and hit enter. Okay, so the update is complete, and use that wget command. You could type facebook.com this time and hit enter. And you should get the IP address for the Facebook server, right? 157 240.229.35, right? So I can actually, let me see if I can highlight all that. It's tricky, right? So, you know what? I'll just type it in. You can actually ping it. You can type ping 157.240.229.35, right? With the space between the G and the ping and the one beginning with 157 and hit enter. So as you see, you're getting a successful echo reply from that web server on Facebook.com. So this is kind of demonstrates how the back-end EC2 instances that are in private subnets actually have internet access. Okay, and that's again through the NAT gateway. The instances in the public subnet use what? Do they use the NAT gateway or do they use just the regular internet gateway? You should know by now, right, that it uses the internet gateway because they already have public IP addresses associated with them. Okay, so you can close this tab and you can go back to your EC2 tab, type EC2, and we'll start off by deleting the server we created. So what you want to do is click on Linux server and go to actions, click on instance setting. Okay, that ain't it. It's instance state. And we want to select terminate, delete instance. So we select terminate. And it's shutting down and it should be terminated soon. Now, what we want to do is for the web server 1 and 2, we just want to stop those instances from running. So we go instance state and we go stop, right? We're not terminating them, we're just stopping them. Okay, and then we want to go to our databases and we want to select RDS. Click on DB instances 2 of 40. Select the My Database and under Actions, we want to select Stop Temporarily. And we want to check the acknowledgments. We don't need to save it in a snapshot. Okay, so I'm selecting the wrong one. Okay, let's do the read replica first. And I'm just trying to do this to save costs. And what I may do is delete the we may just delete the replica. It's probably going to tell me I can't do it. And okay, so what we can do is click on the replica. We can get rid of it. And we'll go delete. And we'll type delete me. And it's deleting. Okay, so it's going to take a while to delete that. And while we're waiting for that to delete, let's go to Elastic IP. And because we have one that's assigned to our gateway, right? This is the IP address. And let's see if we can release that and then delete our NAT gateway. And we want to select release Elastic IP address under the actions. Okay, I know these addresses cannot be because they are associated. Remove the associations. Okay, disassociate Elastic IP addresses. Okay, so we go to actions. Okay, it's Maybe I need to remove the NAT gateway first. This is always a challenge, right? When I'm trying to stop services, there's a certain order in which they need to do. And let's delete the NAT gateway. Okay, so it's deleting the gateway. And then once the gateway's deleted, we could probably disassociate the elastic IP because we really need to do that. We need to release it. Okay, so let's check the status of our RDS. And it's still deleting the. Let's see if we can stop the database now. Stop temporarily. Gonna have to wait for that thing to be deleted. Okay, so it's a good rule of thumb. We'll go back to our EC2s. Okay, our EC2s are not running. If you click on instances, still showing 3, right? One's terminated and 2 are stopped. Hit refresh. That other one should go away. It may take a while for the Linux server instance for that. Once it's terminated, and you can refresh and eventually it'll go away. Well, we're just back to web server 1 and 2. Okay. So let's go back to NAT Gateway. Okay, our NAT Gateway is deleted. Given that's deleted, let's just make sure our elastic IP, we type elastic IP. We should be able to delete it now. Release. Let's go to subnets and route tables. We got to go to route tables, click on the private route. Okay, and let's go to routes. Let's go to edit routes. And let's delete the NAT gateway route. Save changes. Okay, go back to route tables. Make sure there ain't nothing in the, we didn't do a private to route, so let's just click the route table. Okay, that looks good. Let's go to subnets. Let's check on the public subnet, private US East 1, 1A. Okay, there's nothing there. Click on the second one. And click on route table. Nothing there. So what I'm trying to do is release that elastic IP. So the subnets, let's check the subnet associations for the private 1 route. There should be no more associations. Okay, 2. But the routes are gone. Should be able to release that IP. There we go. So you had to remove the route to it in order to release it. So then you can release it. And again, there's a certain order, right? There's a certain dance you have to go through, a certain procedure to get everything released, but this will keep the charges down. And so that means our elastic IP has been released. There's no elastic IP because remember that's a permanent public IP address. Okay, the lab NAT gateway has been deleted. Okay, so you see that under the status. Our security groups are fine. We didn't have to update those. So if we go to databases, RDS. Okay, so again, that replica has been removed. Just click on my database, and we should be able to stop it temporarily. Okay, and there it goes. It's stopping. So the database has been stopped. And we go back to our EC2s panel. Okay, we got no instances running, which is good. And we have still showing 3 instances. One of them's been terminated. That will eventually clear out. Next time you log into the lab tomorrow, it'll be gone. Takes a few hours. Okay, so that completes the lab. You got to see how the NAT Gateway works. And then we actually tested it by creating another EC2 instance in a private subnet, and then using that instance to connect to the internet through the NAT Gateway. Okay, and then we shut down. We got rid of the Elastic IP, we got rid of the NAT Gateway, and then we actually deleted the third EC2 server we created, and we stopped the databases and other instances.